Today we're going to be solving multi-step inequalities, and you should have the foldable that we did in class because you'll be filling out the foldable as we go through the video. It should be on page 1 of your foldable, and I want you to write the definition of an inequality. An inequality is a mathematical statement that compares two expressions using our inequality symbols: less than, greater than, less than or equal to, greater than or equal to. Unlike our equations, you will be graphing the solutions for your inequalities. So on page 2 of your foldable, you need to write the information on how to graph solutions. If I solve an inequality and my variable is greater than a given value, then I'm going to have an open circle over that value, and I'm going to shade to the right, which means that every value to the right of that open circle is a solution to my inequality. If I solve an inequality and it's less than, I'm going to have an open circle over the value, and I'm going to shade to the left. If I solve an inequality and it's greater than or equal to, I'm going to have a closed circle over that value, and I'm going to shade to the right. Now the difference in an open circle and a closed circle is that the value is included when the circle is closed, and it's not included when the circle is open. So last but not least, if I have a less than or equal to, when I solve my inequality, I'm going to have a closed circle over the value, and I'm going to shade to the left. You might want to stop the video and make sure you have this information written on page 2 of your foldable. Now, solving multi-step inequalities is like solving multi-step equations. If you can solve 2x plus 3 equals 11, then you can solve 2x plus 3 is less than or equal to 11. Steps for solving inequalities are the same as steps for solving linear equations, except for step 5. So as we go through the examples, I'll go through the same 5 steps that I did when we were solving multi-step equations. Now in step 5, and that's where you divide, you're going to discover if I divide by a negative, I'm going to reverse my inequality symbol. And you will see this as we go through some of the examples. Okay, you should now be on page 3 of your, you should be on page 3 of your foldable. And as I go through the steps for solving linear inequalities, I'm going to be doing this one example, and we're going to go through the entire foldable with this one example. So on page 3, step number 1 should be to clear all fractions. Notice I have no fractions, so the only thing on page 3 of my foldable is this example written down. 2 times x minus 5 minus 3 times 2x minus 5 is greater than 5x plus 1. On page 4, step number 2 says I need to get rid of the grouping symbols using the distributive property. So I'm going to distribute to remove the grouping symbols. Okay, I have 2x minus 10 minus 6x plus 15 is greater than 5x plus 1. And this is what you should have written on page 4 of your foldable. Then we're going to go to page 5 of your foldable, and it's going to be step 3. Now step 3 is the step where I simplify each side, and we do that by combining like terms. So I look at the left side, and I have 2x terms, and I have 2 constant terms. Well, when I combine like terms, that means I'm going to add those terms. So I'm going to add 2x and negative 10, and I'm going to get negative 4x I'm going to add negative 10 and positive 15, and I'm going to get plus 5. And that is greater than 5x plus 1. And this is what you should have written on page 5 of your foldable. Then we're going to go to page 6. Page 6 is step 4. Step 4 says we want to isolate the variable. Now remember, I told you in class that I like my variable on the left, and there's a reason for that. So I'm going to put the variables on the left and my constants on the right. So I'm going to move the 5x to the left side, which means I'm going to subtract 5x from both sides. I'm going to move the positive 5 to the right, which means I'm going to subtract 5 from both sides. So I have negative 9x is greater than negative 4. And this is what you should have written on page 6 of your foldable. And we're going to go to page 7. And it's step 5. And step 5 is where we solve. And remember, I said to solve, you're going to divide. So I'm going to divide both sides by the coefficient in front of x, which is negative 9. And this is where that rule when you're solving inequalities take place. I am dividing by a negative number. And if I divide by a negative, I'm going to reverse my inequality symbol. So I'm going to have x is less than negative 4 divided by negative 9, which is positive 4/9. Alright, so now I want to graph my solution. So I'm going to have a number line. Okay, we'll say that 0's here, 1's here, negative 1's here, and where's 4/9? 4/9 is less than a half, so we're going to say that 4/9 is here. Now if you refer back to page 2 of your foldable, it says if it's less than, I'm going to have an open circle. So I have an open circle at 4/9, which means 4/9 is not part of my solution, and I'm going to shade to the left. So I'm going to shade my number line to the left, which means that all values on that number line are solutions to my inequality. Okay? Now let's look at another example. Okay, here's example number 2. Now you just might want to write this below on that extra space on your notebook paper. Again, I go through step 1. There's no fractions, so I'm ready for step 2. Step 2 says I'm going to remove grouping symbols, so I'm going to use the distributive property. I have negative 2x. I'm going to distribute a negative 2, so I have minus 2x. I'm going to distribute a negative 2, so I have minus 10. Is less than or equal to, I'm going to distribute this 2x, so I have 2, so I have 2x. I'm going to distribute this 2, so I have minus 8. I've got rid of my grouping symbols. Now I'm going to step 3, which says I need to simplify each side. The only side that needs to simplify is this one. I need to combine these like terms. So I have negative 4x minus 10 is less than or equal to 2x minus 8. So I'm ready for step 4. Step 4 says I need to isolate my variable. I like my variable on the left, so I'm going to move the 2x over, which means I'm going to subtract. I'm going to move the negative 10 over, which means I'm going to add. So I have negative 6x is less than or equal to positive 2. Alright, to solve this, I want to divide both sides by -6. And again, I am dividing by negative. And when I divide by negative, I have to reverse my inequality symbol. So I have x is greater than or equal to, that's a fraction, so it's -1/3. And again, we want to graph our solution. So we're going to have a number line. Zero be here, positive ones here, negative ones here, -1/3 is approximately here. This time there's a bar underneath it, so I have a closed circle over -1/3, and I'm going to shade to the right because it is greater than. And I don't know if you noticed, but since I put my variable on the left, it's always going to be in the direction that my arrow is pointing. And that's one of the reasons I like my variable on the left. Alright, let's look at another example. No fractions again. I have grouping symbols, so I'm going to distribute. I have 3x plus 6 is less than 3x plus 8. Step 3 says to simplify each side. Each side is already simplified. Step 4 says to isolate the variable. I'm going to move my 3x over here, which means I'm going to subtract. So now I have 6 is less than 8. There's no variable. But is that a true statement? Is 6 less than 8? It's a true statement. So this means that any number I put in for x is going to be true. So if I was going to graph this, I would graph the entire number line, because every real number that I put in for x would make that inequality true. Okay, let's look at one more example. Okay, again, no fractions, no grouping symbols. I'm actually going to start at step 3, which means I need to simplify each side. This side is already simplified. I need to come over here and combine like terms. So I have 2x is greater than or equal to x plus x is 2x plus 1. At step 4, I want to move the 2x over here, which means I'm going to subtract it. And I discovered that those cancel, so I have 0 is greater than or equal to 1. Is 0 greater than or equal to 1? No, that's never true, which tells me that this one has no solution. That means there is no number that I can put in for x and have a true solution. Okay, we've gone through 4 examples. Bring your foldable to class, bring these examples to the class, and we'll talk more about how to solve multi-step inequalities. See you later.